Hello, my name's Martin Bors and I work in the product management group for the PLCnext runtime system here at Pinikscon택트. Today I'd like to speak to you about the PLCnext system architecture. Now many of you may have seen a drawing similar to this. It's a very busy drawing and you may say to yourself, what on earth is going on here? So today I'd like to try and make it simpler by going through this step by step. First of all, you need to choose your PLCnext hardware, for example, an AXC F2152 controller. On that hardware, we have an operating system which is built around a Linux kernel with the preempt RT patch, which gives us the deterministic real-time capability for the controller. Now, if you were just to work with this controller, well, that's fine. You can, using our software development kit or using a generic toolchain for this platform, you can write C++ programs, you can install .NET Core and run C# programs, you can run Java programs, you can run Python programs or Rust, you can install Node.js and run JavaScript, or you can install Node packages like Node-RED. So if that's all you want to do with the PLCnext control, that's fine. You can just work directly with the operating system and have access to all the hardware like the Ethernet ports, for example. But each PLCnext control also comes with an automation runtime platform. And this is started up when the operating system starts. Now inside the automation runtime platform is a whole set of components. And the first component I'll speak to you about is the ESM, the Execution and Synchronization Manager. Now this allows us to run deterministic real-time programs without having to worry about all the operating system level details of how to do that. So using the ESM, we can download PLCnext Engineer and we can write IEC 61131 programs using your favorite language, ladder, function block diagram, structured text, sequential function chart. So you can treat the PLCnext control just like any other PLC using your IEC programs. Again, if that's all you want to do with the PLCnext control, that's great, you can do that as well. However, if you have Visual Studio with the PLCnext plugin, you can also write real-time deterministic C# programs. Or if you have MATLAB with Simulink, you can write deterministic real-time programs using MATLAB. And all of these deterministic real-time programs can run together on a PLCnext control and they can all exchange data with each other through the global data space. And this takes care of all the synchronization and the consistency between data that's transferred between programs running on a PLCnext control. So what else does the automation runtime platform give us? Well, it gives us components like field bus components that gives us access to I/O, local I/O and field bus I/O like Profinet and Ethernet IP. It gives us service components like the built-in OPC UA server. And it gives us system components like the user manager for password protection and so on. Now we can further extend the function of a PLCnext control using another component called the Program Library Manager. And using the PLM, we can write non-real-time C++ components using Eclipse with the PLCnext add-in. And these non-real-time PLM components can then provide deterministic real-time C++ programs that run on the ESM. And of course, we can add as many non-real-time PLM components that we like, which can provide as many deterministic real-time C++ programs. And again, that can communicate with all the other real-time programs through the global data space. If we have no need for deterministic real-time programs in C++, we can just use the automation component framework to write our C++ components. So these are non-real-time components written in C++ that have full access to all the services in the automation runtime platform. But how do our components access these services in the ARP? Well, we make use of yet another component, the service manager. Many of the components in the automation runtime platform will publish services called RSC services, for remote service call services. They'll publish those services with the service manager, and then our components can subscribe to those services and interact with those services on the automation runtime platform. In addition, our own C++ components can publish custom RSC services, and other components can subscribe to those services. So all of these options give us many different ways to extend the functionality of the PLCnext control. So I hope that's been a useful introduction to the PLCnext system architecture. If you found this useful, please like this video, subscribe to our channel, and please come and visit us on the PLCnext community. See you next time.